Hi class, we are on page 8 of the notes where we are looking at finding equations of curves. So sometimes you'll be given dy by dx. So the differential of an equation is known as the dy by dx, and you might be asked to work backwards to find the equation of the curve. Okay. So let's have a go at this first question here. It says a curve passes through the point 1, 5, and the gradient function dy by dx is 16x squared minus 6x. Find the equation of the curve. So anytime you see find the equation of the curve, they're asking you to find y equals. Okay, so in this case, I'm going to start with dy by dx. And I am going to work backwards. I'm going to integrate to get y. Now, if you remember from last lesson, you add 1 to the power and you divide by the new power. You add 1 to the power, so this is a power of 1, power of 2 now. Divide by the new power, and don't forget you'll have a plus c. You can tidy that a little bit up. Now, when you have an equation with the plus c, they call that a general solution because you haven't worked out what c would be. Okay, and then they've given me some extra information here. It says it passes through the point 1, 5. So I'm gonna use the fact that x is 1 and y is 5. I'm going to sub it in and work out what c would be. So here I'm going to sub in y is 5. I'm going to put in 1, so 16, 1 cubed. I'll put it in. 6 divided by 2 is 3, so that's 3 times 1 squared plus c. I'm just going to rearrange this. So 5 minus 16 over 3 plus 3 will equal c. So I'm just going to type that into my calculator. 5 minus 16 over 3. Plus 3. Okay, so that gives me that c is 8 over 3. Okay, I wouldn't stop there. I would always write down what my equation is in full with my c in. So therefore, y equals 16x cubed over 3 minus 3x squared plus 8 over 3. And this here is a particular solution. And that's because they gave me some extra information, so I was able to work out what c would be in this example. Okay, let's have a look at the next one. A curve passes through the point 4, 5, and dy by dx is that. Find this equation. So here again, I want to work out what y is. So I'm going to start with dy by dx, and I am going to put this in index form. So that's 3x to the power of half minus 16x to the power minus 2. Okay, I am going to integrate. I'm going to add 1 to the power, 3 over 2, and divide by that new power. I'm going to add 1 to the power and divide by the new power, plus c. Okay, they've given me some extra information for 5, so I'm going to sub that in, like that. So I've got 5 equals. Now this bit you can simplify. I mean, you could use a calculator and type in 3 divided by 3 over 2, like that, okay, to give you 2. Or you've got to remember that when you divide by a fraction, you flip it and you multiply. So you'd be multiplying by 2/3, and then 3 on the top would cancel with the 3 on the bottom, okay, which would leave you with that 2. Minus divided by a minus is plus 16. X to the power minus 1, I mean, you could live it like that, but you know it means 16 times 1 over x plus c. I was meant to put in the 4. I'll put it in now. So 5 equals 2, 4 to the power 3 over 2 plus 16 over 4 plus c. And from there you can work out what c is. So here I'm going to do 5. I'm going to take off 2 times 4 to the power of 1.5. That's 3 over 2. Plus 16 divided by 4, that's 4. That gives me, oops, done that wrong, haven't I? Because I should be taking that off. Give me that c is 15. So I'm just going to write c is 15. And then your final step is to make sure that you've written the full equation with your c value in. There you go. And that's the equation of the curve. Okay. One more. So here they've given us a curve has f dashed x, so that's the gradient function, is e to the x plus 3. It's got a y-intercept of 8. Find its equation. So f dashed x is e to the x plus 3. Okay, so I've got to integrate that. So if you integrate e to the x, it stays the same. Okay, e to the x. You integrate a constant, you get x term 3x plus c. And then they've given me this extra information. They've said the y-intercept is 8. Now remember, y-intercept means when x is 0, y is 8. So I'm going to sub in x is 0 and y is 8. So 8 would equal e to the 0 plus 3 times 0 plus c. So 8. Now e to the 0, you should know anything to the power 0 is 1. So I'm going to take off 1. That's 0 would equal c. So c is 7. Therefore, f of x is e to the x plus 3x plus 7. Okay, and that is finding equations of curves. Okay, the other thing I'm going to teach you today, so I want you to stop the video now, and I want you to do these questions on exercise 13C from the first book, page 294. So questions 1 to 4, quite basic. The slightly harder ones are 10 to 15. Okay, so pause the video and then come back to do the next page with me. Okay. So the next page is looking at definite integration, and that's where we find a value to represent the integral between two limits. Now your calculator, I mean I'm using the old style calculator, can find any real definite integral, but when it comes to more complex functions, it might be a little bit harder. So the button I'm actually talking about is this one here. That means integrate a function. So if I typed in x, where's x? X, it's in red, x squared. Okay, we put some limits in, 0 and 2, and it gives you the answer. Okay, the only issue is in the exam you'd have to show a working of integration, but you could use this as a way of checking your answer. Okay, so here, show that the value of the definite integral 8x cubed plus 2x integrated with respect to x between the limits of 2 and 3 is 135. Okay, so the first thing you do is what you've been doing before, which is you integrate. So if you integrate, you would get 8x, oops, should be filming this, 8x power 4 over 4 plus 2x squared over 2. And here, because this is definite integration, you do not put plus c. Okay, what you do is you put these square brackets on and you put in your limits, x is 2 and x is 3. I'm going to tidy that up a little bit because I can see I can simplify that. So this bit here is 2x power 4 plus x squared between 2 and 3. Okay, now what you do is you always put your top limit in first. Okay, so I'm going to put in x is 3 into this expression here, to power 4 plus 3 squared. Okay, and I'm also going to put in my smaller, well, my lower x value there. So I'm going to put that in. Okay, there you go. And you have to do a subtraction, and you always do a subtraction between these two values. So here, particularly because the answer is given, you've got to show you're working. So 2 times 3 to the power 4 plus 3 squared, which is 9. That's 171. I'll just write that down. The other one, that's 2 to the power 5, isn't it? That's 32 plus 4. That's 2 squared. That gives me 36. And it's 171 minus 36 is 135, which is what they wanted. Okay, so it's not hard. You just do what you did before. You integrate, you put in your top limit, you put in your bottom limit, you do a subtraction. Top limit minus bottom limit. There you go. Okay, let's do another one. So here, find the following definite integrals showing all steps. Part 2, that'll be that one, will be in terms of k. So this is how they try and get around you guys using your calculator in the exam. They might put a constant in where you can't just type it into your calculator. All right, so I'm just gonna have a look. What I'm going to do there before I integrate is I'm going to tidy that up. There's two ways of doing this. So I could do 4x minus 1, and I'm going to take the x to the power 4 to the top, and it becomes x power minus 4. Okay, and I'm going to multiply these two. So this has got a power of 1. If I times these two, I'll get 4x. 1 take minus 4 is minus 3. That times that is that. And this is what I'm integrating. So this means integrate with respect to the letter x. Doing the integration, you add 1 to the power, divide by the new power, add 1 to the power, be careful with your negatives, divide by the new power, put your square brackets on, put your limits on, okay? And then I think I'll probably tidy up a little bit. So here I have got 4 divided by minus 2, which is minus 2, x power minus 2. And I have got minus and a minus makes a plus x to the power minus 3 over 3. Okay, and there's my limits, 1 and 2. Put your top limit in, so put in x is 2. So if I do that, and then I'm going to put in my bottom limit, minus 2 times 1 to the power minus 2 plus 1. Okay, and then remember, you're always doing a subtraction. So top limit minus bottom limit. It's always an idea to show you're working. In the exam, I mark for Edexcel, and they nearly always have a mark. As long as some of your working is right here, it doesn't have to be all correct. They do give you follow 3 marks if you have clearly shown that you're subbing in your limits and you're doing a subtraction, top minus bottom. Okay, so I'm just going to work each value out. So again, reach for your calculator. You don't have to do it by hand. Obviously, you could do plus 2 to the power minus 3. Plus, put my fraction up. 3. So that gives me minus 11 over 24. The other one, I am just going to overwrite all my 2's that are subbed in with a 1. Just check that. Yep. So that's minus 5 over 3. And you are subtracting. So you have essentially got minus 11 over 24. And then you've got minus and a minus makes a plus, plus 5/3. Which is 29 over 24. And that's the value of the definite integral, that one there. And if you wanted to, you could check on your calculator, have I done it right? So I'm going to try and use my button here. 4, what am I doing with it? I need an x. X minus 1 over x to the power 4. My limits are 1 and 2. Thinking about it, 29 over 24, which is what I got, what I've shown on my working. Okay, so that can be your check. Right, let's do another one. I'm just checking if there's any more. Yeah, there is. Okay, so this one here, I am going to integrate just like before. So I am going to do x cubed integrated is x power 4 over 4. A constant integrated becomes an x term, so that's kx. Put your limits in. I'll have 2k at the top and k at the bottom. And then I'm just going to sub in my terms, so my letters into the expression. So don't overthink it. All right, sub in your top limit. Sub in your bottom limit. K times k, which is k squared. All right, and then let's tidy up. So 2 to the power 4 gives me 16. K to the power 4 over 4 plus 2k squared. Be careful when you're subtracting. So here I've got minus k to the power 4 over 4. Minus and a plus makes minus k squared. Collect your like terms. So here 16 divided by 4, that gives me 4k to the power 4. And I'm taking off a quarter k to the power 4. And I'm a tad lazy, so I am just going to type it into my calculator, which gives me 15 over 4k to the power 4. And then how many k squareds do I have? I've got 2k squared minus k squared, which gives me 1k squared. I suppose you could factorize that, but it doesn't ask you to, so that's it, you stop. Your answer is in terms of k. Okay, let's do, I think it's one more over the page. So given that a is a positive constant and the integral value is log 7, Show that A is ln k, where k is a constant to be found. Okay, so again, don't overthink it. All right, there's an integral. Integrate it then. Okay, put your limits in. Put it equal to log 7. All right, so I'm just going to organize my work by splitting the page up. You might want to do that as well, particularly if you've got big writing. I'm going to, before I integrate, I'm going to manipulate that. So t plus 1, I'm going to put the t to the top so it has a power of minus 1. And if I expand my bracket, so this has a power of 1, remember. If you are timesing, you add the powers. So that gives me t to the power 0, which is 1. And that is just t to the power minus 1, like that. And we are integrating with respect to t. My limits are a and 2a. If you integrate, remember it's not x now because it says with respect to the letter t. With respect to the letter t. So here I'm going to integrate that. That's going to give me t. Integrating t to the power minus 1, that is ln t. We did that last lesson. And then I'm going to put my limits on, a, 2a. Okay. I'm going to sub in my top limit. So it'll be 2a plus ln 2a minus a plus ln a. And I know that's going to equal ln 7. Okay. I'm going to tidy up. So I've got 2a minus 1a, so that gives me a, I'll just write that. And I've got log 2a minus log a. So I'm just going to write that, log 2a minus log a, like that. And that has to equal log 7, all right? Now I know loads of logarithms that when you are subtracting log, you can combine that into one log. So that becomes log of 2a over a, okay? Still equal to log 7. I can cancel my a's there. So I have got a plus ln 2 is log 7, like that. And then I need to get a on its own. So I'm going to say log 7 minus log 2. And I'm going to rewrite that as one log. Again, subtracting two logs, one subtracted from the other. You can combine it by doing a division. Show that a equals ln k. My k is a constant to be found. K is 7 over 2. Done. Okay, there you go. Nice question. All right, so what I'd like you to do after you've done these examples here is from the Year 1 textbook, page 297, question 2 to 4, and from the Year 2 book, which are a tad trickier, but do them, don't leave them out, do questions 3 to 7. Okay.